Hello friends, welcome back to Learning Python. So today in this video we are continuing with our lecture on SLR Parser. In the last tutorial we already designed this DFA. So please prefer my last tutorial on SLR Parser. Okay. Now today what we are going to do with the help of this DFA, okay, we are going to construct this SLR parse table. Okay. Now first of all let us see what is the structure of SLR parse table. The SLR parse table consists of two columns, okay, where one column is dedicated for your action part and the other column is dedicated for the go to part. Okay. Here friends, in action part, the action part includes your terminals. Okay. How many number of terminals used in your grammar, that much number of columns are present inside your action column. Okay. Now friends, the second part consists of your goto, okay, and this goto we are having the number of non-terminals. Okay, how many number of non-terminals we are having in our grammar, that much columns will be present on your goto part. Okay, this is all about your action and goto. Now friends, here the number of rows are equal to the number of states we have in our DFA. Okay, here in this DFA, starting from I0 to I11, we have total 12 number of states present. So we have 12 number of rows in our parse table construction. Okay, so let me explain once again. In this we are going to design a structure of parse table. Okay, this consists of two parts. First part is action and the second part is goto. Now in action part we are having the total number of columns equals to total number of terminals present in our grammar. Okay, and in goto part the total number of columns will be equal to the total number of non-terminals present in our grammar. Okay, and the number of rows will be equal to the number of states we have in our DFA design. Now what we need to do, we have to find out the first and follow for every production. Why friends? Because with the help of these follow elements, okay, with the help of these follow elements, what we have calculated, we will be using this for some reduce operations. Okay. Now, as we have already read that there are four possibilities, okay, four number of actions we can perform. First one is shift, second one is reduce, third one is your accept, and the last one is error. Okay, in the last video friends I already discussed, okay, what is the use of this e dash derives e. Okay, this extra state is added in your augmented grammar. Okay, so this extra state or your production, this extra production is added in your augmented grammar because to have a except state. Okay, because when we are reaching to your start state, start of the start symbol, okay, that where here e is the start symbol, okay, in this grammar. Now when we are reaching to the start symbol, then there must be some production, okay, which will accept the start symbol, because here we are doing the rightmost derivation. So we are having this extra state, that is e dash derives your e. Now after finding this follow, okay, now we are going to construct your parse table. Now we have mainly two important set of operations. First one will be your shift operation and the second one will be your reduce operation. Okay, and one important operation that will be accept operation, and that accept operation will be always present in your first state. Okay, from I0 to I1, when we are having a transition of e, or when we are having the shifting of e, then we are having e dash derives e dot. It means that we have successfully compiled, or we have successfully completed the scanning of this production. So in I1, okay, in I1 for dollar symbol we have accept. Okay, we will write the accept action in your first state, that is I1, and in dollar symbol. Okay, now in I0 friends, okay, in any state, what we need to do, we have to see is we have any set of production available which has already scanned all its production on the right hand side. Okay, it means that if the dot is present on the right handmost side of any of the production, then it simply means that we have successfully scanned all the productions. Okay, but in I0, friends, we can see that none of the dot is present to the right handmost side of the production. It simply means that in this state we are not having a single reduced operation. So we are having a shift operation, and the shift operation will be carried out here with this terminal. Okay, now as we know that for go to we are having the non-terminals. Okay, so from I0 to I1 we can go by this non-terminal, that is E. Okay, so from I0 to I1 we can go with E. So for state 0, okay, with E we can go to I1. So we will write here 1. Okay, it means that from state 0, okay, with the symbol E we can reach to state 1. Okay, now we will repeat the procedure again for T in the same manner. Okay, that means that we are going to have a transition from state 0 to state 1 with a symbol T. Okay, so we will write here 2. Okay, we are having another non-terminal F. Okay, means that we are having a transition from I0 to I3 with this symbol F. So we will write here 3. Okay, this much for the go to part, because we are having only 3 non-terminals available here for this I0 to any other state. Outgoing symbol we are having only 3 non-terminals present over here. Now what we are going to do now, we are having a terminal here. Okay, for state 5 from I0 we are having a ID. It means that we can reach from state 0 to state 5 with a shift operation of ID. Why, friends? Because here we are not having any reduce operation. Okay, so we simply having the shift operation. So from I0 to I5 we can reach by using this ID. Okay, so we are having S5. We are having a shift operation from this state 0 to state 5. Now we are having a symbol here, that is left parenthesis, from I0 to I4. Okay, friends, from I0 to I4 with this shift operation, that is S, we are having S4. Okay, so we can go to S4 with, okay, so we can have this shift operation for the left parenthesis, because from state 0 we can go to state 4. Okay, with this left parenthesis. Okay, so what we need to do, the state where we are going, okay, that state number we have to include in the shift operation. Okay, for example, in this here we are going from state 0 to state 4. Okay, with this left parenthesis symbol. So it simply means that after passing this left parenthesis symbol we are reaching from a state 0 to state 4, then we will write S4. Okay, now in the left parenthesis of the 0th state. Okay, now friends, what we are going to do, I am going to tell you a state where we are having a reduce operation. Okay, so we are having a reduce operation in this state. So friends, focus here. For I2, okay, for I2 E derives T dot. It means that for this production has completed its execution. Okay, has completed all its scanning, because the dot symbol is present to the rightmost. Okay, so here we can reduce this with the left hand side. Okay, now in the grammar we have given, okay, in the given grammar, what we need to do, we have to see is E derives T present in our grammar. Okay, yeah, it is present over here. okay, the production number 2, we have E derives dot T. It means that E derives T can be produced from this grammar, that is from this production number 2 of your given grammar. Okay, so what we need to do, we have to reduce, okay, with the help of this production number 2 in the grammar. Now where we need to reduce, which symbol we need to reduce, we have to reduce to all the, now we have to see that what is the left, what is present to the left hand side, okay, what is present to the left hand side of the production, that is E. Okay, so on the left hand side E is present. So now we will see what are the elements present in the follow of E. Okay, so elements present in the follow of E are dollar plus and your right parenthesis. So here we will reduce in state 2, okay, for dollar we will perform the reduce operation by this production because E derives T, okay, and here E derives T. It means that this production can be reduced, this production can be reduced to the given production, that is production number 2 of your grammar. So we have the reduce operation for the production number 2, but where in the action part where we have to fill the reduce operation, that is R2, okay, reduce operation for the production number 2. So we will find, we have already find out the follow of every non-terminals. So what we are going to do, we are having a reduce operation to all the symbols present over here. Okay, so in dollar we are having R2, in plus we are having R2, okay, in right parenthesis we are having R2. Okay, so simply we have to cover all this in the similar manner. Okay, so this is all about your construction. I am just completing this table. Okay, so you just complete it. If you find any difficulty, do contact me or do post in your comment, in my comment section of this channel. Okay, so after the successful completion of the parse table, okay, we will get this final instruction. Okay, so just go through it. If you find any difficulty, do comment in the comment section. Okay, and okay, this much. After we will contact in the next tutorial. Okay, I will be taking a string and we will check the belongingness of the string to the grammar. Okay, for the timing, stay tuned to learn it by fun. Do like, share, subscribe the channel. Bye bye.